In the next few lessons we're going to look at redox reactions. Now redox stands for reduction and oxidation reactions. So whenever a redox reaction takes place, there is always going to be reduction and oxidation taking place at the same time. Now in this lesson we're going to look at the conventional definition of the redox reaction, and this definition really refers to the loss or gain of oxygen from a substance. So when oxidation is taking place, we say that oxygen is gained by a substance, and when reduction occurs we say that oxygen is lost by a substance. So let's just consider as a simple example the reduction of copper to oxide by carbon. This is a reaction that you're well familiar with. Black copper oxide powder is mixed with soot with carbon powder, and the mixture is heated, and after a while copper appears and carbon dioxide is produced. So in this reaction we can say that copper oxide is losing oxygen. Oxygen is being lost, so we can say here that reduction is occurring. That's to say the copper oxide is reduced. Although we call this reaction the reduction of copper to oxide, I want to emphasize this, that whenever a reduction reaction occurs there's always an oxidation process going on as well. So in this case actually it's the carbon that is gaining an oxygen, so we say the carbon is oxidized, and so we can also say that oxidation is taking place. So we have both reduction and oxidation. Now, whenever reduction is taking place and oxidation in a reaction, there is always an oxidizing agent and a reducing agent. The oxidizing agent is the substance which supplies oxygen in this conventional definition, while the reducing agent is the substance which removes the oxygen. So in our simple equation here, which is the reduction of copper to oxide, carbon is the reducing agent, because carbon is removing oxygen from the copper oxide. Now, although you wouldn't conventionally think of copper oxide as a typical oxidizing agent, in the context of this reaction it is an oxidizing agent because it's supplying oxygen to the carbon to produce carbon dioxide. So in this reaction we can call it the oxidizing agent. So let's have a look at another example. This time we'll look at the thermite reaction. Now the thermite reaction is a reaction between aluminium and iron oxide. It's also known as a displacement reaction because the aluminium displaces the iron from the iron oxide to produce aluminium oxide and iron. So we can say in this case aluminium is reducing the iron oxide. Okay, the iron oxide is reduced and the aluminium therefore is the reducing agent. Now at the same time that the iron oxide is being reduced, that's to say it's having its oxygen removed, the aluminium is being oxidized. It's picking up an oxygen to form aluminium oxide. So we can say that the aluminium is oxidized and that the iron 3 oxide in this reaction is the oxidizing agent. Okay, so we've got reduction taking place, the iron oxide is having its oxygen removed, and we've got oxidation taking place, the aluminium is gaining oxygen to form aluminium oxide. Now I'd also like to refer to what might be commonly known as classical oxidizing agents or reducing agents. By classical I mean a substance which is often bought with the purpose of being able to supply oxygen for a particular experiment. For example, potassium nitrate or hydrogen peroxide would be termed oxidizing agents. So if you were to buy these substances from a chemical supplier, they would come in a bottle or a jar with the following symbol attached to them. Okay, this symbol would tell you that these are oxidizing agents. That basically means that they will readily decompose to supply oxygen. In the case of potassium nitrate, which is also known as saltpeter and is actually used in the manufacture of gunpowder, this will readily decompose into potassium nitrite and oxygen on heating, while hydrogen peroxide will decompose on its own into oxygen, but this decomposition can be assisted by a catalyst called manganese dioxide. And you can see a video of this reaction in the practical demos section on the website. Well, while those are our classical oxidizing agents, our typical or classical reducing agents would be carbon monoxide, hydrogen and carbon. So in the case of the reduction of copper oxide, this isn't true for all of the metal oxides, obviously, because it depends on their position in the reactivity series. Well, for example, carbon can be used as a reducing agent, or carbon monoxide, or hydrogen in this case.